So next is the wireless sensor networks. These wireless sensors networks, the name itself suggests that they are the uh, wirelessly connected networks, right? And these networks are mainly the usage of the wireless made up of smart objects, which are sometimes they're called as a motors. Okay, and the fact that there is no infrastructure to consider with WSNS is surely a powerful advantage for flexible deployments, but there are a variety of design constraints to be considered with these wirelessly connected smart objects. So the some of the most significant limitations of these smart objects in wireless networks are limited processing power, limited memory, there is a lossy communication, and limited transmission speeds and limited power. Okay, so these limitations are greatly influence on the some of the most significance of these are this one. These limitations greatly influence how WSNs are designed, deployed, and utilized. The fact that individual sensor nodes are typically so limited is a reason that they are often deployed in a very large numbers. As the cost of the sensor nodes continues to decline, the ability to deploy highly redundant sensor becomes increasingly feasible because many sensors are very inexpensive and correspondingly inaccurate. The ability to deploy smart object redundancy allow for increased accuracy. Smart objects are limited processing, memory power, and so on are often referred to as a constrained nodes. Okay, so these example you see there, these the diagram we can see they have moderate CPU power. Okay, and the power consumption is also very critical. Energy efficiency is paramount. Battery power devices must last years, right? And narrowband media is maximum of 250 kilobits per second, lower rates in the normal, right? Lossy communication, that is a low power wireless mesh speedometry IEEE 802.15.4, also IEEE P1902.1, that is a power line communications, and you have the low memory, few tens of kilobytes embedded in the operating system. Okay, so these such large number of sensors permit the introduction of hierarchies of the smart objects, such as hierarchy providers we call. Among other organizational advantages, the ability to aggregate similar sensor readings from sensor nodes that are in close proximity to each other. So this diagram is an example of such a data aggregation function in a wireless sensor networks where temperature reading from a logical grouping of temperature sensors aggregated as an average temperature reading. See, this is the diagram which illustrates the the data aggregation in wireless sensor networks. You can see the average temperature. If you take all the nodes temperature, if you aggregate it, it will be around 11.7 degree Celsius. These data aggregation techniques are helpful in reducing the amount of overall traffic. Okay, so the and energy also. In WSNS are very large number of deployed smart objects. This data aggregation at the network edges is where fog and moist computing takes place. IoT network architecture and design are critical IoT architecture elements needed to deliver the scale and performance of required by so many IoT use cases. While There are certain instances in which sensors continuously stream their measurement data. This is typically not the case. Wirelessly connected smart objects generally have one of the following two communication patterns. So that one is a event driven, the other one is a periodic. So when you come to the event driven, transmission of sensory information is triggered only when a smart object detects a particular event or predetermined threshold value, right? And the periodic communication is a sensory information that occurs only at a periodic intervals. That is, it may be weekly, daily, or hourly basis or monthly basis, right? The decision of which these communication schemes is used depends greatly on the specific application. Okay. If you take example in some medical use case, sensors sense periodically post post-operative vitals such as temperature or blood pressure readings. In other medical use cases, the some blood pressure or temperature readings are triggered to be sent only when certain critical low or high readings are measured. As WSNs grow to very large number of smart objects, there is a trend toward ever increasing levels of autonomy. For example, manual configuration of potentially thousands of smart objects are impractical and unwieldy. So smart objects in WSNs are typically self-configuring or automated by the IoT management platform in the background. Likewise, additional levels of autonomous functions are required to establish cohesive communication among the multitudinous nodes of large-scale WNS that are often ad hoc deployments with no regard to uniform node distribution and density. For example, there is an increasing trend towards smart dust application in which very small sensor nodes are scattered over a geographic area to detect vibrations, temperature, humidity, and so on. This technology has practically limitless capabilities such as military, for example, detecting enemy troop movement, environmental, for example, detecting earthquake or forest fires, and industrial, for example, if you take a detect manufacturing anomalies, asset tracking. Some levels of these self-organization is required for networking the scards of wireless smart objects such that these nodes autonomously come together to form a true network with a common purpose. This capability to self-organize is able to adopt and evolve logical topology of the wireless sensor network to optimize communication, that is among the nodes as well as the centralized wireless controllers, simplify the introduction of new smart objects, and they improve the reliability and access to services. Additional advantages of being able to deploy large numbers of wireless low-cost smart objects are the inherent ability to provide fault tolerance, reliability, and the capability to extend the life of WSN, especially in scenarios where the smart objects have limited battery life. Autonomous techniques such as self-healing, self-protection, and self-optimization are often employed to perform these functions on behalf of an overall wireless sensor network systems. The IoT applications are often mission critical, and in large scale wireless sensor networks, the overall system cannot fail if the environment suddenly changes. Wireless communication is temporarily lost. So our limited number of nodes run out of battery, power up function or improperly. That is the reason why we are going to call as a lossy networks, right? So lossy network, and we have to limited power supply. Everything is limited when you go for the wireless sensor networks. Okay. Then this wireless sensor networks grow very large number of smart objects that trend toward the increasing levels of autonomy. Organizing is required for networking and SCADs. This capability of self-organizing able to adopt and evolve the logical topology of the wireless sensor network to optimize the communication. Okay. So wireless sensor networks are become increasingly heterogeneous with more sophisticated interactions. Wireless sensor network are seeing transitions from homogeneous wireless networks made up of mostly single type of sensor to networks made up of multiple type sensors that can be even hybridized mix of many cheap sensors with a few expensive ones used for very specific high precision function. For example, WSN has multiple type sensors and one of those types is temperatures that can be flexibly concurrently environment of other applications and smart farming applications also. So now when we want to increase the quality of the wireless sensor networks, communication maybe, power maybe, processing speed maybe, we need some protocols that called as a communication protocols for wireless sensor networks. There are literally thousands of different types of sensors and actuators. To further complicate matters, WSNs are becoming increasingly heterogeneous with more sophisticated interaction. This heterogeneity is manifested in a variety of ways. For example, if you take a WSNS or seeing transitions from homogeneous wireless network made up of a mostly single type of sensor to networks made up of multiple type sensor network or even be a hybridized mix of many cheap sensors with a few expensive ones used for a very specific high precision functions. WSNS are also evolving from single purpose network to more flexible multi-purpose networks that can use specific purpose types for multiple different applications at any given time. Imagine that your WSN has multiple types of sensors and one of those types is a temperature sensor, and that can be flexibility used concurrently for environmental application, weather applications, and smart farming applications. So if you take a coordinated communication with sophisticated interactions by constrained node devices within such a heterogeneous environment is a quite challenge. So if you take the protocols governing this communication for wireless sensor network must deal with the inherent defining characteristics of wireless sensor networks and constrained devices within them. Any communication protocol must be able to scale to a large number of nodes. Likewise, when we are going to selecting a communication protocol, you must carefully take into account the requirement of the specific application and consider any trade-offs the communication protocol offers between power consumption, maximum transmission speed, range, tolerance for packet loss, topology optimization, security, and so on. The fact that the wireless sensor networks are often deployed outdoors in harsh and unpredictable environment. So, hey guys, welcome back to our new video. और इस वाले वीडियो में guys हम लोग करने वाले हैं not all communication, in fact, that often deployed in outdoors and harsh unpredictable environment. Yet another variable to consider because of obviously not all communication protocols are designed to be equally rugged. In addition to the aforementioned technical capabilities, they must also enable as needed. The overlay of autonomous techniques, for example, self-organization, self-healing, self-configuration in the previous section. Wireless sensor networks interact with their environment. Sensors often produce large amounts of sensing and measurement data that needs to be processed. This data can be processed locally by the nodes of WSNS or across zero or more hierarchical levels of in IoT networks. These hierarchical levels are we are going to discuss in the future sections. Communication protocols need to facilitate routing and message handling for the data flow between the sensor nodes as well as from sensor nodes to optional gateways, edge compute or centralized cloud compute. IoT communication protocols for WSNS thus straddle the entire protocol stack. Ultimately, they are used to provide a platform for a variety of IoT smart services. As with any other network applications, in order to interoperate a multi-vendor environments, these communication protocols must be standardized. So this is a critical dependency for IoT and one of the most significant success factors when related to the when we are going to talk about the YSNS, WSNS. IoT is one of those rare technologies that impacts all verticals and industries, which means the standardization of making the communication protocol is a complicated task which requires protocol definition across multiple layers of the stack as well as a great deal of coordination across multiple standards development organizations. Recently, there have been a focused efforts to standardize a communication protocol for IoT, but as with the adoption of many significant technology movement, there has been some market fragmentation. While there isn't a single protocol solution, there is beginning to be some clear market convergence around several key communication protocols. We do not spend time, okay, here we are going to discuss some of these basic specific protocols and their detailed operation because we are going to concentrate on the wireless sensors, actuators networks are the unique computing platform that can be highly distributed and deployed in a unique environment where traditional computing platforms are not typically found. This offers unique advantages and opportunities to interact with and influence those environment. This is the basis for the Internet of Things and opens up world of possibility, embedding sensors and actuators in everyday objects and networking the enable sophisticated and well coordinated automation that improved and simplifies our lives. This is the introduction of the things that are building blocks of the IoT. So description of practical examples of the sensors, how they are going to able to measure them environment. They provide the same sort of actuators which are they're going to act, which are the environment sensing information in a complementary way to act on their surroundings. So, and recent manufacturing trends in the MEMS toward making the sensors and actuators ever smaller and more embedded in a everyday objects. Thus, smart objects, which are typically highly constrained devices with the sensors and actuators along with very limited power transmissions and compute capabilities. Okay, we unlock the power of IoT by networking smart objects, sensors and actuators network, that is a SUNETs, which is a particular attention detail given to the case of wireless sensor network. So communication protocols for wireless sensor network which sets you up for a the connecting the smart objects. So that is a standardization means communication protocols is a complicated task which are going to require the protocol definition across multiple layers of the stack, as well as a great deal of the coordination across a multiple standards development organization. These communication protocols need to facilitate routing and message handling properties. That is the things for data flow between the sensor nodes, as well as from sensor nodes to the optional nodes, as well as from gateways, edge compute, and centralized cloud computing devices. Since the sensors are going to produce a large amounts of sensing and measuring data, okay, the fact that the wireless sensor networks are often deployed outdoors in harsh and unpredictable environments adds yet another variable to consider, because of obviously not all communication protocols are designed to be equally rugged. Okay, so this is all about the smart objects and the wireless sensor networks and the so protocols which we are going to use, communication protocols for WSNS. So how we are going to improve the quality of the communication by defining the protocol and by bringing the homogeneous elements to the heterogeneous elements in the wireless sensor networks, right? So multiple types of sensors will be there. So we have the different sensors we are going to use. This is all about the about how the IoT networks is going to use the different sensors, actuators, and wireless sensor networks, becoming the increasingly heterogeneous with more sophisticated interactions. Okay, that is all about the wireless sensor network, actuators, and the sensor networks.